Welcome to the Python Talk with Egloword IT Solutions podcast. In today's episode, we dive into the exciting world of Python frameworks and libraries. Whether you are building web applications, diving into data science, or exploring artificial intelligence, it's essential to stay up to date with the latest tools that can supercharge your Python development process. Join us as we explore the best Python frameworks and libraries that are making waves in the tech community. Regardless you are a seasoned Python developer or just starting your coding journey, this episode will provide valuable insights and recommendations to enhance your productivity and build robust applications. Let's dive into the world of Python frameworks and libraries together. Starting with the introduction. Python is often labeled as a versatile and beginner-friendly programming language. In addition to this, it comes with various pre-packed libraries which can help developers by saving development time and effort. As pointed out earlier, Python has a sea of libraries available. This is one of the biggest reasons why Python is popular among the developer community. But as it is said, there is another side of the story as well. As helpful as it is to have hundreds and thousands of libraries at your disposal, it can also become a tedious task to select the best Python framework and libraries as per your project requirements. Moving on to the core topic: best Python frameworks and libraries to use in 2023. Well, Python has a vast ecosystem of frameworks and libraries which greatly enhance the development process and empower developers to build robust and efficient applications. From web development to scientific computing and machine learning, Python has a solution for nearly every domain, making it the popular choice in the code learning community along with experienced professionals. Next, we will discuss about the top Python web development frameworks and software libraries that we have utilized in projects for our clients. Number 1. Django. You cannot start any Python framework list without adding Django in it. Django is a high-level web framework that simplifies web application development. Django emphasizes on dry aka don't repeat yourself, and comes with ready-to-use features like a login system, database connection, and CRUD operations. It follows MVT, which stands for Model View Template Architecture. It also provides tools that manage database management, URL routing, template rendering, user authentication, and more. With a focus on reusability and maintainability, Django framework in Python is popular for building robust and scalable web applications. Now, let's explore the next area, which is Django framework key features. Django provides an object relational mapping that simplifies database interaction by using Python objects. It follows Model View Template Architecture, promoting code organization and reusability. It includes a robust URL routing system for mapping URLs to views. Django's template engine separates the presentation logic from the business logic. Built-in form handling in Django provides features like form validation and error handling. Django emphasizes security with built-in measures to protect against several web vulnerabilities. It also supports internationalization and localization, allowing the development of global applications. Django is designed to handle high traffic loads efficiently, making it scalable and performant. Moving ahead, Django framework is used to build web application development, content management system, e-commerce platforms, social networking platforms, data analytics and visualization, APIs and web services. Shifting gears to the next topic. Number 2 on the list is Pyramid. Pyramid is a lightweight and flexible Python web framework that prioritizes simplicity and customization. With the minimalistic approach, it gives developers complete control over the application structure and components. Designed for scalability and performance along with various features including different URL patterns, supports multiple templating engines, and built-in features for authentication and authorization. In addition to all this, it also has comprehensive documentation and an active community, making it a popular choice for developers who are looking for customizable Python web dev frameworks. Proceeding to the next segment, key features of Pyramid web framework are: Pyramid emphasizes simplicity and minimalism, allowing developers to selectively add necessary components. URL dispatching in Pyramid provides a powerful mechanism for handling diverse URL patterns and HTTP methods. Pyramid supports multiple templating engines, enabling the separation of presentation and application logic. Built-in features in Pyramid facilitate authentication and authorization for secure user access control. Pyramid offers flexibility in configuration through Python code or files, catering to project-specific needs. Testing and debugging are made efficient in Pyramid with robust utilities and a debugger. It also supports middleware, enabling integration of additional functionality and customization of request-response processing. Pyramid is compatible with various deployment options, including servers, WSGI containers, and cloud platforms. Pyramid benefits from an active community and comprehensive documentation, providing valuable support and resources. Moving ahead, Pyramid framework is used to build custom web applications, content management system, API and web services, single-page applications, prototyping and proof of concepts, enterprise applications, microservices, real-time applications. Moving ahead to the next subject matter. Number 3 on the list is rate greater than Bottle. The Bottle is a fast, simple, and lightweight WSGI micro web framework for Python. With its minimalistic design and small code base, it is easy to use. The Bottle is distributed as a single file module, which helps it in integrating with the projects without much complexity. It is an ideal choice for small to medium-sized web applications and prototyping, as it provides inbuilt support for routing, handling HTTP requests and response, as well as working with templates. Moving ahead to the next subject matter, key features of Bottle Web Framework. Bottle's lightweight and simple design offers a minimalistic approach to web development. Its built-in URL routing capabilities for easy request mapping. Bottle supports convenient handling of HTTP requests and responses. It provides various templating engines. Supports built-in user session management. Simplified handling of client file uploads. Easy processing and validation of form data. Features for building RESTful APIs. Advanced plugin support for added functionality. Easy integration with no complex setup or installation. On to the next topic. Bottle framework is used to build single-page applications, small projects, microservices and APIs, web services and utilities, educational projects, and more. Proceeding to the next item on our list is Tornado. Tornado is a high-performance Python web framework and asynchronous networking library. This best Python framework for web development is known for its ability to handle thousands of simultaneous connections with low latency. Tornado is popular for building scalable, real-time web applications and APIs, thanks to its asynchronous I/O capabilities, request handlers, templating engine, and integration flexibility with existing applications. Apart from all this, it includes its web server, supports WebSockets, and employs an event-driven architecture for efficient handling of concurrent requests. Now, let's explore the next topic. Tornado Python Web Framework key features are: Tornado supports asynchronous I/O for efficient handling of concurrent requests and non-blocking operations. It uses built-in web server, eliminating the need for additional servers like Nginx or Apache. WebSockets support real-time bidirectional communication, request handler model for routing and handling different types of HTTP requests. Templating engine for generating dynamic web pages. Security features include secure cookies, input validation, and XSS protection. Scalability with the ability to handle large numbers of concurrent connections. Integration flexibility with existing applications or frameworks. Active community and comprehensive documentation, providing resources and support for developers. Moving ahead, Tornado framework is used to build real-time application, web APIs, streaming services, WebSockets application, asynchronous microservices, and more. Let's explore the next item on our list, which is Flask. Flask is a lightweight and flexible Python web framework used for building web applications and APIs. It emphasizes simplicity and minimalism, providing the essential tools for web development. With a built-in routing system, a templating engine for dynamic content, and extensibility through various plugins, Flask Framework Python enables developers to create small to medium-sized web applications, prototypes, and RESTful APIs efficiently. It is highly regarded for its simplicity, ease of use, and flexibility, making it one of the most popular Python frameworks. Proceeding to the next segment, key features of Flask framework are: Flask is a lightweight framework that enables quick and efficient development of web development. Flask provides a flexible and intuitive routing system for different types of HTTP requests. The powerful templating engine in Flask allows for dynamic content generation and seamless integration with HTML templates. Flask's extensibility allows for easy integration of additional functionality through a wide range of plugins and extensions. It is highly compatible and versatile, making Flask a seamless integration with other Python libraries. Python Flask Web Framework facilitates easy testing and debugging due to the inbuilt development server. Flask WTF extension simplifies integration with forms, form validation, and security features for user input handling. Flask has a vibrant community and comprehensive documentation, providing valuable resources and support to developers. Its modular design enables scalability, allowing for easy expansion and management as projects grow. Turning our focus to the next point, Flask framework is used to build web applications, RESTful APIs, prototypes and experimentation, custom solutions tailored to specific requirements, and more. Moving on, number 6 on the list of best Python frameworks and libraries to use is AIO-HTTP. AIO-HTTP is a Python library mainly used for building asynchronous HTTP-based client and server applications. It leverages Python's Asyncio library for the efficient handling of concurrent requests, making it ideal for developing high-performance and scalable web applications, APIs, and web scraping tools. AIO-HTTP supports various HTTP features like WebSockets, cookies, sessions, and SSL, TLS encryption. It provides an easy-to-use API for making HTTP requests and handling responses asynchronously, enabling developers to build efficient and responsive applications that can handle many concurrent connections. Pivoting to the next topic of discussion, let's talk about some key features of AIO-HTTP technology. AIO-HTTP is designed for handling asynchronous HTTP requests, allowing for efficient concurrency and responsiveness. Using AIO-HTTP allows developers to build a complete web application as it provides both client and server-side functionalities. AIO-HTTP allows real-time bidirectional communication between servers and clients using built-in WebSocket communication support. AIO-HTTP supports various HTTP features such as cookies, sessions, SSL, TLS encryption, content compression, and authentication. It allows the use of middleware components to customize and extend the functionality of the application. It also provides flexibility in deployment options as it can help in integrating with different Asyncio, Gunicon, and UWSGI. AIO-HTTP allows efficient content streaming, which enables the processing of large files or streaming responses to clients. AIO-HTTP provides a routing system for mapping URLs to specific handlers, making it easy to define and handle different routes in an application. It provides tools and methods for testing applications, making it easier to write test cases for various functionalities. Turning our focus to the next point, AIO-HTTP framework is used to build asynchronous web applications, RESTful API, web scraping, real-time applications, microservices, and more. Directing our attention to the next item on the agenda is pre-commit. Last but not the least in our list of Python frameworks is pre-commit. Pre-commit is a popular Python framework and command line tool used to maintain code quality by running configurable checks and fixes before committing changes. It integrates with the version control systems like Git, executing pre-commit hooks on each commit. With pre-configured and custom hooks, it enforces code formatting and style guidelines. Enforcing quality standards, ensures clean and compliant code, improving overall code-base quality and reducing potential issues. Proceeding to the next segment, key features of pre-commit web framework are: pre-commit allows developers to configure a set of hooks, specifying the tools and checks to be run before committing code. It seamlessly integrates with popular version control systems like Git, automatically triggering pre-commit hooks on each commit. Pre-commit provides a wide range of pre-configured hooks for common tasks such as code formatting, linting, and more. Developers can define their custom hooks to run specific checks or perform additional tasks based on project requirements. Certain hooks in pre-commit can automatically fix issues, saving time by applying fixes before committing changes. Pre-commit optimizes performance by running only the necessary hooks on modified files, reducing unnecessary checks on unchanged code. It can be seamlessly integrated into existing development workflows, allowing for smooth adoption and integration with CI/CD pipelines. Pre-commit works across different operating systems, making it suitable for projects with diverse development environments. It provides an easy-to-use configuration file format, allowing developers to define hooks and their configurations clearly and concisely. On to the next topic. Pre-commit framework is used to build enforcing code style, code linting, security checks, automated testing, commit message, dependency management, continuous integration, documentation validation. Now, progressing to the next area of interest. And next item on the list is requests. The requests library is a popular Python library used for making HTTP requests. It provides a simplified and intuitive API for sending HTTP requests and handling responses. With requests, developers can easily perform common HTTP operations such as get, post, put, delete, and more. The library supports various authentication methods, cookies, sessions, and SSL, TLS encryption. It also offers convenient features like automatic content decoding, JSON parsing, and file uploads. Requests are widely used for web scraping, interacting with RESTful APIs, testing web services, and building web applications that rely on making HTTP requests. Moving forward, let's discuss about the key features of Requests Library. The Requests Library offers a user-friendly and intuitive API for simplifying the process of sending HTTP requests and handling responses. Requests support various authentication methods like BASIC, Digest, and OAuth, ensuring secure communication with authenticated APIs. The library provides support for sessions and cookies, allowing for efficient and stateful interactions with web applications. Requests seamlessly handle SSL, TLS encryption, ensuring secure communication with servers that require it. It provides convenient methods to access response headers, content, and status codes, simplifying the extraction of relevant information. Requests automatically decode content based on response headers, making it easy to handle compressed or encoded responses. The library includes built-in JSON parsing, simplifying the handling of JSON data returned from APIs. Requests support file uploads as part of HTTP requests, making it useful for transferring files or making multi-part, form data requests. Developers can easily set custom headers and query parameters in requests, allowing for flexibility in specifying request details. Requests provide support for making HTTP requests through proxies, enabling communication with services behind firewalls or within restricted networks. Delving into the next subject. Requests Library is used for web scraping, API integration, authentication and authorization, data collection and aggregation, testing web service, and more. Proceeding to the next item on our list, which is NumPy. NumPy is a Python library used for numeric computing. It provides efficient multi-dimensional array objects and functions for mathematical operations. With its powerful array manipulation capabilities, NumPy is widely employed in data analysis, scientific research, and machine learning. It serves as the footing for developing various other scientific and data-oriented Python libraries. NumPy has become essential for performing advanced numerical computations in Python with the functionalities like array indexing, slicing, and linear algebra operations. Now, let's explore the next area. NumPy Python library key features are: NumPy provides efficient multidimensional array objects for numerical computing. It offers a wide range of mathematical functions and operators for element-wise operations on arrays. NumPy supports broadcasting, enabling operations between arrays of different shapes. It provides flexible indexing and slicing capabilities for accessing and manipulating array elements. NumPy includes comprehensive linear algebra functions for matrix operations and solving equations. It seamlessly integrates with other scientific Python libraries for data analysis and computation. NumPy's array operations are implemented in optimized C code, ensuring fast and efficient computation. Turning our focus to the next point. NumPy library is used for data analysis and manipulation, scientific computing, machine learning, financial modeling, computational physics, data visualization, robotics and bioinformatics. Number 10 on the list of best Python frameworks and libraries to use is Pandas. Pandas is a Python library used for data manipulation and analysis. It offers high-performance data structures like data frames and series, along with functions for data visualization and transformation. It provides powerful data indexing and slicing, handles missing data efficiently, and seamlessly integrates with other Python libraries like NumPy and Matplotlib, making it a valuable tool for data-centric workflows. Moving on, some of the key features of Pandas Python library are: it supports data frames for efficient manipulation and analysis of structured data, data cleaning and handling of missing data, data transformation operations like filtering, sorting, grouping, and reshaping, flexible indexing and slicing for extracting subsets of data, time series analysis with date, time indexing and operations, Integration with other libraries like NumPy and Matplotlib, data visualization capabilities. Input-output support for various file formats. Flexible data structures beyond data frames, such as series, panel, and multi-index. Moving ahead, Pandas Python library is used for data cleaning and pre-processing, exploratory data analysis, data wrangling and transformation, time series analysis, financial analysis, machine learning and data modeling, business intelligence and reporting, data visualization. Let's explore the next item on our list, which is Pillow. Pillow is a popular Python library for image processing and manipulation. It provides a wide range of functions and methods for opening, editing, enhancing, and saving images in various formats. The Pillow supports basic image operations like cropping, resizing, rotating, and flipping. It also offers advanced image processing capabilities such as filtering, blending, and color adjustments. With Pillow, you can handle image metadata, apply text and graphic overlays, and perform image format conversions. Advancing to the subsequent subject, which is key features Pillow Python library. Pillow provides functions for image manipulation, including resizing, cropping, rotating, flipping, and adjusting image attributes. It offers tools for image enhancement, such as brightness, contrast, sharpness adjustments, and color correction. The Pillow supports image filtering operations like blurring, sharpening, edge detection, and noise reduction. It can read, save, and convert images in various formats such as JPEG, PNG, GIF, BMP, TIFF, and more. The Pillow allows access and modification of image metadata, including AXIF data. You can add text and graphic overlays like watermarks or annotations to images using Pillow. Pillow facilitates conversion between different image formats. Stepping into the next phase, Pillow Python library is used for image processing and editing, web development, machine learning, digital media and content creation, data visualization, scientific research and analysis. Continuing our exploration with next the item on the list is TensorFlow. An open-source machine learning library termed TensorFlow was created by Google. It features strong support for deep learning and machine learning, as well as a modular numerical computation core that is applied across many different scientific fields. Using several platforms, including but not limited to CPUs, GPUs, and TPUs, is made simple by the flexible design. Multiple layers in the deep learning models allow for the learning of complicated patterns and data representation. Pivoting to the next topic of the discussion, TensorFlow ML library key features are: TensorFlow utilizes graph-based computation to represent and execute complex mathematical operations. For efficient gradient computing during neural network training, TensorFlow provides automatic differentiation. It offers flexibility to develop and train scalable modules across various platforms including CPUs, GPUs, and distributed systems. TensorFlow has a rich ecosystem, with trained models and access to popular datasets for diverse machine learning and deep learning tasks. TFX, TensorFlow Extended, provides end-to-end support for machine learning libraries and tools developed on TensorFlow. TensorFlow includes TensorBoard, a web-based visualization tool for analyzing and monitoring the training process. Moving forward, TensorFlow Python library is used for image classification and object detection, natural language processing, anomaly detection, speech recognition and synthesis, recommendation system, and more. Number 13 on the list is scikit-learn. Scikit-learn, also known as sklearn, is an open-source machine learning library for Python. It provides a comprehensive set of tools for various machine learning tasks, as it is built on NumPy, SciPy, and Matplotlib. It is designed to be user-friendly, efficient, and accessible to both beginners and experienced machine learning practitioners. Moving on, some of the key features of scikit-learn Python library are: it offers a wide range of algorithms for classification, regression, clustering, and dimensionality reduction. Provides tools for data pre-processing and feature engineering. Functions and metrics for model evaluation and selection. Seamless integration with data pipelines. Interoperability with other Python libraries like NumPy, Pandas, and Matplotlib. Extensibility and customizability for implementing and integrating custom machine learning algorithms. Turning our focus to the next point, scikit-learn library is used for classification, regression, clustering, dimensionality reduction, and more. Proceeding to the next item on our list is PyTorch. An adaptable and effective library for creating and training neural networks is provided by PyTorch, an open-source deep learning toolkit for Python. It offers smooth model building and optimization using a dynamic computing graph and GPU acceleration. Backpropagation is made easier by its automatic differentiation feature, which also seamlessly connects with the Python ecosystem. PyTorch is a popular research tool that offers resources for model deployment in real-world settings. Now, let's explore the next area, key features of PyTorch library. PyTorch's dynamic computation graph allows for flexible model architecture changes and easy debugging. With efficient GPU acceleration, PyTorch enables faster tensor computations for improved training and inference speed. PyTorch's automatic differentiation simplifies backpropagation by calculating gradients automatically. The extensive collection of pre-built neural network modules in PyTorch facilitates model development with readily available components. PyTorch's Pythonic interface seamlessly integrates with the Python ecosystem, enabling easy data manipulation and integration with other libraries. PyTorch's flexibility and popularity in the research community make it a preferred choice for experimenting with novel model architectures and ideas. PyTorch provides tools like TorchScript and ONNX for exporting and deploying models in production environments and on various platforms. On to the next topic. PyTorch library is used for image classification, time series analysis, research and prototyping, transfer learning, generative models, natural language processing, object detection and segmentation. Last but not the least, on the list of best Python frameworks and libraries to use is OpenCV, aka Open Source Computer Vision. OpenCV is a widely used open-source library for computer vision and image processing tasks. It offers a comprehensive set of functions and algorithms that enable tasks such as image and video manipulation, object detection and tracking, facial recognition, and real-time computer vision applications. OpenCV supports various programming languages, including Python and C++, making it accessible and versatile for a range of computer vision projects. Delving into the next subject. OpenCV library is used for. OpenCV provides a wide range of functions and algorithms for image and video processing, enabling tasks like resizing, filtering, and frame extraction. With pre-trained models and algorithms, OpenCV facilitates object detection, tracking, and recognition in images and videos. OpenCV includes tools for feature extraction and matching, essential for tasks such as image stitching and 3D reconstruction. It offers functions for camera calibration, allowing for accurate geometric measurements and image rectification. OpenCV seamlessly integrates with machine learning frameworks like TensorFlow and PyTorch, enabling the development of end-to-end computer vision pipelines. Optimized for real-time applications, OpenCV provides functions and techniques for real-time object detection, tracking, and augmented reality. OpenCV is cross-platform and supports multiple programming languages like Python, C++, and Java, making it accessible for developers on various platforms. Supported by a large and active community, OpenCV provides extensive documentation, tutorials, and code samples for easy adoption and learning. Turning our focus to the next point. OpenCV library is used for object detection and tracking, facial recognition and biometrics, augmented reality, video and image recognition, object detection and tracking, robotics and machine vision, medical imaging, gesture recognition. Let's turn our attention to the following topic. Things to consider while choosing from the list of Python libraries. It can be a headache to select the best match of Python library for your project when there are n number of libraries available at your disposal. However, there are a few things that you need to keep in mind while selecting the top Python libraries which can help you in making an informed decision. Let's discuss about them. First thing you need to consider is purpose. One of the most fundamental checks you should perform is that the library you are choosing meets your needs. It's crucial to consider whether your project and the library's primary functionality align. What features will it have? Or what problems you must resolve to make sure the library you pick complies with those demands. Second, is documentation. Proper documentation is must-have for a library. Check if the library has comprehensive and up-to-date documentation. The documentation should clearly explain the features, functionalities, and usage examples. Clear documentation can save a significant amount of time and effort spent on understanding the functionalities of the library. Third, is community support. Consider the size and activity of the library's community. A strong and active community can provide valuable support, answer your questions, and contribute to the library's development. Look for active forums, mailing lists, GitHub repositories, or other online communities associated with the library to get a better idea about the library's activity. Fourth thing you need to ponder upon is maintenance and updates. Check the library's maintenance history and the frequency of updates. An actively maintained library with regular updates is more likely to have bug fixes, new features, and better compatibility with the latest versions of Python and other related libraries. Fifth is popularity and adoption. Check the library's maintenance history and update frequency. Popular libraries usually have a larger user base and are more reliable, well-tested, and actively maintained. They also have more community resources and third-party integrations available. Sixth is compatibility. Another important thing that you need to take into consideration is compatibility. Ensure that the library is compatible with the version of Python you are using. Some libraries may only support specific Python versions or have limitations with certain platforms or operating systems. Check the library's documentation or website for compatibility information. Seventh is performance. Consider the library's performance characteristics. Depending on your use case, you may need a library that is optimized for speed, memory usage, or scalability. Look for benchmarks or performance comparisons if available. Eighth is licensing. Check the license under which the library is distributed. Ensure that the license aligns with your project's requirements and that you are comfortable with its terms. Common licenses for Python libraries include MIT, Apache, GPL, and BSD licenses. Ninth is dependencies. Examine the library's dependencies and consider any potential conflicts with other libraries you are using. Libraries with minimal or well-managed dependencies are generally easier to integrate into your project. Lastly, reviews and recommendations. Read reviews and recommendations from other developers or experts who have used the library. Their experiences and insights can provide valuable information about the library's strengths, weaknesses, and suitability for your specific use case. In conclusion, Python's diverse range of Python frameworks and libraries, including Django, Flask, NumPy, Pandas, and TensorFlow, offer developers a versatile and powerful toolkit for developing robust applications. With the support of frameworks and libraries, Python becomes an ideal language for web development, data science, and machine learning, providing productivity, efficiency, and community-driven support. Egloword hopes you enjoy the audio. For more details, go to www.egloworditsolutions.com. Thanks for listening.